Okay, thank you everyone for coming. I'm Richard Lee. I'm one of the founders of Datawire, and we actually started the Telepresence project back in the day, really born out of just challenges of coding on Kubernetes. And over the past few years, we've learned a lot about how you develop on Kubernetes. The entire ecosystem has changed completely. And so what I'm here to talk a little bit about is the impetus for Telepresence and how we developed it, and share with you sort of our perspective, and for those of you who are new to Telepresence. And then Christian actually is going to talk a little bit about how he integrates Telepresence into his workflow, and then I'll talk a little bit about the future of Telepresence. So just show of hands, how many of you folks have actually heard of Telepresence? Oh, okay, a lot of people. And how many of you are actually using it? Okay, a lot fewer. Okay, so good to know. So the inner and outer development loop, right? So this is a concept I'm sure is familiar to lots of folks. This guy from Microsoft did an excellent blog post around the inner development loop. But essentially, if you're coding microservices or any sort of program, it doesn't need to be microservices, you have an inner loop as a developer. You write some code, you might build your code, then you test it a little bit, right? And then once you convince yourself that it works, right, that's good enough, so you commit the code, right? And you do this over and over again, and at some point you get to the point where you want to share this code with someone else, and so you create a pull request, and that's what triggers your outer loop. And the outer development loop is something that looks pretty similar to your inner loop, but it's really optimized around sharing, typically characterized by integration tests, continuous integration system, right? But generally speaking, that's the outer loop. And one of the key things to recognize about the inner loop versus the outer loop is that in the inner loop, latency is a really, really big deal, right? So if you add an extra 5 seconds to your inner loop, that really gets your developer mind to kind of wander a little bit, and maybe, and the longer it takes, you might start reading Hacker News, and suddenly you forget what your actual code is supposed to do, right? And versus the outer loop, where if it takes an extra 5 seconds, you probably don't notice because, you know, it's not a big deal. Now, if it takes an extra 5 hours, then you might want to click that retry button in Travis a lot more often. But generally speaking, it's really about reducing latency in that inner loop, right? So in Kubernetes, initially, and this has evolved a little bit, but the inner and outer loop for Kubernetes, it typically is the same, right? So you write some code, but instead of just building your service, you build a container that contains your code, then you push to a registry, then you deploy to a cluster, and then you test, right? And this actually can be a little slow. And so the classic engineering answer to this has been, how do we do automation? And so there have been a proliferation of tools over the past few years. Microsoft introduced Draft, right? Google then said, oh, we don't like Helm, so we're going to do Scaffold, right? Which is not Helm. But it's kind of like Draft, but not really, right? And then various startups like Garden and Windmill has Tilt and GitCube, and I'm sorry if I forgot who else. I mean, there's so many in the space that I can't remember. But they all sort of do the general thing of trying to speed up your entire development loop, right? And the challenge these tools face is that they still rely on this Docker build, Docker push thing. And as we just talked about in your inner loop, you want it to run as fast as humanly possible. And so there's an intrinsic limitation to how fast your development loop can run when you're using Draft or Scaffold or any of these other tools. And the other challenge is when you're doing development, you tend to want to use your own tools. And so Microsoft has done a great job of integrating Draft with VS Code, and VS Code's great. But what if you want to use a different code editor, right? Or what if you want to use a debugger or profiler? And so each of these tools needs to be integrated with your particular deployment tool and workflow on a case-by-case basis. And frequently, unless you're using the most common tooling, it doesn't actually work super well. So then there came another school of thought, and this is not super linear, but so the alternative to this historically has been to do everything locally. So it's really fast and you can use your tools. And that's where tools like Minikube and Docker for Kubernetes, and before that it was Docker Compose, could work really well. And this actually lets you be fairly productive around this. The challenge, of course, is that your laptop only has 16 gigs of RAM. My laptop I bought last year still only has 16 gigs of RAM. And you're asking it to run Kubernetes and a JVM and a database and all your other microservices. And by the way, because you're on Kubernetes and your VP of engineering loves microservices, they keep on spinning up these new teams, and suddenly you have 100 microservices, and they only need a little bit of RAM, but then you have 100 times a little bit, and that turns into a lot. And so you can't actually run all your stuff locally anymore, right? And so that's where telepresence comes into play, right? So what is telepresence? And I've been trying to explain telepresence for a long time, and I've tried to explain it in different ways. So I think about it as I've tried different things, so I'm going to try everything with everyone here. So it's a fancy Kubernetes VPN for development, not for production, because when we explain how it actually works, people get scared, and I say, don't worry, you don't need to run this in production. It's kubectl port forward on steroids, and more generally speaking, it's just a network bridge between your laptop and your Kubernetes cluster, right? So it makes your laptop a virtual node, and I use this term super loosely, it's not really a virtual node, on your Kubernetes cluster, right? And what it does is you run a client on your laptop, and then you run a service locally on your laptop, A prime. And what we do is you have service A running in your cluster, and what we do is we cunningly, or scarily, depending on your point of view, we swap out that deployment in your cluster of service A for a proxy, right? And that proxy will then proxy those requests from the cluster all the way to your laptop, right? So the net effect is when service C wants to talk to service C sends a request to our proxy, which is masquerading through the magic of Kubernetes labels and all that sort of stuff. It takes that request and it forwards it onto the laptop, right? Service A prime on the laptop. And when A prime on your laptop wants to talk to service B or service C, we proxy that request to your cluster, right? And telepresence is doing a whole bunch of things behind the scenes. It actually invokes a bunch of IP tables rules on your local laptop to intercept DNS, to delegate that DNS to your cluster. This is not recommended for the faint of heart. We've actually discovered how on different flavors of macOS, there are all these different ways you can intercept DNS. We also proxy your environment variables and secrets from your cluster to your laptop. We proxy volumes, and of course, we proxy your TCP, right? So the net effect is A prime thinks, or for all practical intents and purposes, it feels like to A prime that it's running on Kubernetes, but it's not, right? And all your other services are still running in Kubernetes, right? So the benefit is you can use any tool that runs on your laptop, right? Whether it's an IDE, profiler, debugger, it doesn't matter. You get effectively unlimited compute because most of your stuff is running in the cloud. You get the same network namespace, so your local server or local application is running the same network namespace as everything in your cluster. You get a very fast inner loop because we've eliminated this Docker build, Docker push step, right? But there's no free lunch, right? Because it does require a network connection. For larger organizations, you need kube control access to the cluster. Because at least at our company, no one runs Windows. We only run on Mac and Linux. There's no intrinsic reason not to run on Windows. I'm told that if you use Windows subsystem for Linux, there are ways to get it to work, but none of us actually run Windows subsystem for Linux. So if anyone wants to step up to be a maintainer for Windows, speak to me afterwards. I'll give you a T-shirt. So we're a CNCF project. We have a wide variety of users. So one of our users from Germany is actually going to be speaking. And it's a big part of a lot of people's development workflows. I think once you sort of understand how telepresence actually works, right, and I'll show a demo in a second, usually the challenge is how do I integrate it into my development workflow? And that's what I think is some of the more interesting questions. And so just to reiterate, you really don't want to try this at home, right? So capturing the DNS and routing only part of it to the cluster, it's tricky. We've discovered that no two laptops are the same. So Datawire is really more of a server infrastructure software company where everything runs in Kubernetes. And there's some amazing things about the fact that if everyone runs Kubernetes, it's pretty much the same thing, kind of. but no two laptops are actually alike, and it makes debugging and troubleshooting telepresence very tricky. We do all sorts of Kubernetes magic around swapping out your real deployment for this proxy deployment. It turns out that's actually complicated. So anyway, so I'm going to do a super quick demo, and I'm going to go here. So I have a cluster running in GKE, and I'm going to increase my font size. Actually, so what I'm going to do is I'm going to just start Telepresence, and I have kube control access to this cluster in GKE, and if I could move this window. And so it's going to create this VPN-type connection to the cluster. And one of the things, it's one of the reasons why, and we're addressing this, and I'll talk about this in a little bit, it takes a few minutes, or a few seconds, minutes, whatever, to start up, is because it's actually deploying this proxy in the cluster every time you invoke the command, which turns out not to be totally necessary. So let's see, here we go. And so now, so I'm still on my local file system, so this is my Mac file system. So I can get pods, right? So you see a bunch of stuff running. So I have a service called the tour backend service. So I can do something like curl tour backend, and I get this JSON blob back, right? So so essentially I'm running the curl that's local on my laptop, right? And I'm sending it, DNS is being intercepted, so it's doing a DNS lookup locally on my laptop, and it's figuring out how to send that request to this server that's running in this remote Kubernetes cluster somewhere in GKE. So that's sort of just the basics of it, and then I can exit Telepresence. So with that sort of in mind, I'm going to bring up Christian to talk a little bit about how he uses this in his workflow.
Okay. Is this really working? Okay. Basically, I'm Chris Raja. I'm software developer for Engel & Volkers, which is a real estate company. We have 11,000 employees and millions of customers worldwide. And recently, we started to undergo the process of transferring all the data from the legacy systems to the new microservices inside the cloud. So in order to achieve this, we needed some sort of synchronization service, right? Because we cannot let the data in the new services go out of sync with the services that are still running, the legacy ones. And with this many customers, we cannot just shut down the old systems without having previously really tested the new systems. And we encountered a big issue, which was that, well, our architecture grew really fast. We have right now 7 microservices that are handling our single source of truth, and we have multiple protocols for the legacy systems. We have Active Directory, we have SQL, we have APIs. So this was not really easy to maintain. And the problem was that at some point, we just decided to start to push and deploy before testing the code, because on our machine, it was not possible to actually test the code. Docker Compose is just too heavy when you have this many services. Mocking the services themselves, when you have so many protocols, it starts to be tricky to have enough test data to actually be sure that you're testing the right way. So we just started to build on the machine and then just push and deploy and let the pipeline run. If something goes wrong, you have to make the changes and you have to deploy again. This takes 5 minutes, 10 minutes every single time you have to deploy. So last year we met Telepresence at the last KubeCon, and we immediately loved this kind of product. We immediately saw the potential that it had inside our workflow, so we started to experiment with it and we started to integrate it. So our workflow right now works in such a way that engineers, when they have to change a microservice, not just a synchronization one that is responsible for the synchronization, but any microservice, they can check out the repository, they can build the image locally, and then use Telepresence in container mode. So this way, it doesn't matter how complex is the architecture, we can always run the service on our machine and debug on our machine. And this allows us to be really fast, to make adjustments and changes locally very, very quickly. And this enabled us to be able, again, to quickly deploy and efficiently deploy on our clusters. So yes, this is our workflow today, and it's much, much faster and efficient than the one we were using before Telepresence came in.
Great. All right, thank you, Christian. So I'm going to talk a little bit about what's next, and then we'll take questions. So if you think about the Telepresence architecture, there's basically two components to it. There's the client, which runs on your laptop, which does the work of capturing your DNS requests for your Kubernetes resources. And I should actually talk about a little bit that one of the complexities of this is we don't want to intercept every single one of your DNS requests. We want to figure out which DNS requests actually are really requests for stuff in the cluster versus if you want to go to, say, google.com, we don't necessarily want to intercept that DNS request, right? We want to do DNS resolution for your Kubernetes resources. That happens on the client. And then it's that proxy from, we proxy the TCP connections from your laptop to the cluster. And then in the cluster, we have a proxy server, right? So, which proxies your TCP connections back to your laptop. And it also is the canonical DNS for all your Kubernetes resources. So those are the two components. So on the client side, the way it works today is we use kubectl port forward to bootstrap an S-shuttle, which is an SSH-based VPN. We tried a bunch of different VPN-type solutions, and turned out S-shuttle seemed to be the most reliable. The challenge is S-shuttle actually has a bunch of functionality that is not used by Telepresence. I mean, it's a VPN after all, and we're not really building a full VPN. So what we actually have started doing is we've written this thing called Teleproxy, which is written in Go, designed for Kubernetes, and it just does some very simple things on the client, right? Which is all we need to do. It does that DNS local capture, DNS resolution, and it redirects TCP connections to the right destination. It doesn't do anything else. And so we've actually embedded Teleproxy into Telepresence. So you probably don't know this, but we were, because essentially Telepresence is written in Python, and we figured out how to embed this Go library essentially into Telepresence, and we'll be exposing that as a replacement for the VPN TCP method. And it also will let us do multiple simultaneous sessions, which has been a popular request to the cluster. So that's what we plan on doing, and we think it will also really improve reliability, et cetera. We've been using Teleproxy internally for quite some time. It's also we also make this API gateway called Ambassador, and we actually use Teleproxy we deploy Ambassador into the Kubernetes cluster, and we use Teleproxy locally because we run our test client locally on our laptop to drive traffic through Ambassador. And we can open up, like, I think we open up 40 parallel HTTP requests, and we drive hundreds of requests per second through Teleproxy to the Kubernetes cluster. So it actually turns out to be something that we think is reasonably reliable and gives us more control than S-shuttle. So that's what we're doing on the client side. And on the proxy server, doesn't really need change. It's not really the world's most sophisticated piece of software. But one of the things is every time you swap out that deployment, we redeploy that proxy server, which is silly, right? So we're actually planning on switching to a mode where your proxy server is actually persistent. So you deploy a persistent proxy, and because, after all, Kubernetes is designed to run persistent services, and there are two real benefits to that. One is startup is much faster, because as you saw, startup is a little slow. And one of the reasons for that is because we're downloading this Docker image and deploying this proxy server. And then the other thing is it will support reconnect. So there are people who work on trains with spotty internet, and so they can do a little bit of coding, and then they can reconnect. So the other challenge that we've been thinking a lot about is multi-user development. So the model that we show in Telepresence, and this is probably the most common question we get once people get up and running with Telepresence, it's if you're swapping out a deployment, right? I'm running A prime on my laptop, but if Christian is trying to code against the same cluster, Christian's sending a request and he's talking to my laptop, A, which is probably not optimal, and B, to the point about inner loop, if I want to be able to break my service whenever I want, and that's probably not what Christian wants to do if Christian's working on service C, right? So the answer we use today, and that folks tend to do, is we recommend either each developer gets his or her own cluster or his or her own namespace. But it is more expensive because there's more hardware and it's set up. And it also, the other thing is it delays integration testing until after commit, right? Because you're not constantly updating every single service in your cluster. You basically are writing some code, you're snapshotting everything, and then you're letting your outer loop actually do that integration testing. So a thing that we're working on, and this is part of our commercial product, but we're experimenting with different versions and iterations, is what we call intercepts. So the user actually goes through an API gateway, and we actually deploy a sidecar, which is the yellow thing, in front of the actual service, right? So there's a sidecar in front of A, and there's a sidecar in front of B. And basically, the sidecar actually can do a request inspection. It looks at the headers. And if the header actually belongs to me, for example, instead of routing it to B, it will actually route it to B prime, right? So if it's a developer request, but if it's a user request, right, then it will just route to B. So essentially, you get the essence of multi-user development in sort of a nice sort of encapsulated model. So I'm going to be slightly daring, and I'm going to try to show this. Oops, that was not the right thing to show. So essentially what I have here is I have this application running, this node application running on, let's see if this is, oh, look, see, the demo gods are not frowning at me. Let's see here. So I have this node app running on localhost 3000, and, oh, see, it's not running anymore. There's something funny. Okay, I can't show the demo. I haven't actually done anything, but it's a shared cluster, so I think, okay. Anyway, you'll have to see this is why we haven't actually released it or anything. So, but the general principle is you'll be able to set a host header and say, going to Jane dot, whatever, that's my sort of personal development site, so I can actually preview changes. While if I go to production dot whatever, then I can actually see the production instance. And based on the host header, we can actually do that dynamic routing. So just to wrap it up, we are looking for folks to help contribute to Telepresence. I think that we don't plan on doing most of the work around Telepresence really around reliability and working in different environments. And so that's really a challenge that can really only happen if we have more folks who actually try it out and give us feedback. So we built in automatic bug reporting around this. And it's a pretty low-level engineering problem, but we actually find it really valuable. Or a lot of people ask questions around how can you improve the documentation. I know it's not necessarily the most glamorous thing, but that's definitely an area where folks can really help. And also, we're always really interested in real-world use cases around workflows, because the question is, how do I integrate this with my Spring Boot app or whatever, right? We have a Slack, so if you want to join it, we're happy to also help out. And if you want to send me an email or tweet about it, feel free to contact me here. And Christian did a talk yesterday about how they use Telepresence with Bazel, the build system from Google that only Christian understands. So if you want to learn more about what they do, he did a great job yesterday. So with that, that's it. Anyone have any questions? Yeah, back there. So the question is, for authentication, how frequently does it happen? And the answer is, authentication basically is built around kube control. So so essentially, we use kube control to bootstrap and do the port forward. So if you have writes at that point in time, then you can do whatever you want. And there's a list of RBAC roles that you need, so you don't need full RBAC access. But that's the only point we do authentication. We don't do authentication at any other point in time. Yep, right here. Do I happen to know if Telepresence works with Istio? With a sidecar? Yes. So I know it works. There is a company out in New York City called Namely that gave a great talk. What they do is they have this monolithic Rails app, and they run Istio. And what essentially they can do is they can actually take a request based on the developer header, and Istio does all this fancy routing stuff. And so they could say, Jane's request gets routed all the way to Jane's laptop. So similar to some of the things I was trying to demo earlier. And so they were able to do that. I do know that there was some amount of engineering they had to do, and we haven't had a chance to actually sit down with them to understand. So I know it's definitely possible. I also know they are a very tech-savvy team, so I don't know how much work it was for them to do that integration. Yeah. Did you have a question? Got it. Yeah, so the question was a little bit more about the Telepresence architecture with respect to what it does in the Kubernetes cluster. And essentially, it creates a Kubernetes deployment. So, and so we create a Kubernetes deployment with the same labels as your existing Kubernetes deployment. And there's a way, you don't have to always do it this way, but that's the most common way. So that way, and then we basically do a kubectl scale to 0 of your existing deployment, and we scale up the deployment containing our proxy. So that's basically what happens. Yes? Will the multi-user be available in open source Telepresence, not a commercial product? I think the answer is we'd like to make that possible. But right now, we're trying to make sure that we have enough resources to invest in both the open source and the commercial. So right now we're going to start with the commercial and kind of see how that goes, and then, but we're basically open sourcing most of the stuff into the core product. Yeah. So. Any other? Oh, yep, back there. Yeah, so the question is, it can sometimes be tricky getting Telepresence to work with a VPN, and will teleproxy make a difference? And the answer is yes. So one of the reasons is S-Shuttle is a full-blown VPN, so it is really not super compatible with other VPNs. So teleproxy, we actually have gotten it to work with one of our customers' VPNs. So we know it's possible. It doesn't require. It requires every single VPN tries to intercept your packets in some way, and so we can't figure out a super scalable way to do it other than, hey, install a VPN and then try and see what happens at the client level. But teleproxy makes it much easier for us to support other VPNs. Yeah. So I think if it's a proprietary VPN, it's much harder for us to support because we obviously we're not going to purchase every single proprietary VPN and try it on our laptop. So, yep. Yeah, so the question is, given the complexity, did we ever consider registering a node, registering the proxy as just a node port? Oh, registering the machine as a node in the cluster. Oh, I see. I don't think I don't know if we've actively explored that option. So I don't know if it's any better or worse. In our experience, like, there's some intrinsic complexities to this space, and we feel like at this point with teleproxy, we actually have a reasonable mental model around how to make this work reliably. And we actually have a bunch of, and also just through brute force engineering, because we have a lot of users, we've been able to debug and troubleshoot a lot of the common cases. So in general, telepresence works reasonably well out of the box for a lot of users. Just because we've been steadily, every time someone reports a bug, we like figure out some other boundary case. Yeah. Great. Well, thank you everyone for coming. Okay.